Hi, everybody. Welcome to the IDE seminar. We are thrilled to have with us this week Professor Anjana Susarla, who is the Omora Saxena Professor of Responsible AI at Michigan State University. Anjana has agreed to take questions in stream, so you don't have to wait to the end. If you would like to ask a question, go ahead and unmute your microphone or type it into the chat. Outside of that, though, please leave your microphone on mute, and we will open it up. We'll have some time at the end for a general Q&A. And Anjana is going to talk to us today about a topic that is absolutely near and dear to everyone's heart. Is consuming social media actually bad for your health? And to sharpen the question a little bit, is consuming social media about your health good or bad for your health? Anjana, over to you, please. Thank you for joining us.
Good afternoon, everyone. I'm so delighted to be here and talk to all of you about my research. So my talk is going to be, I'm going to spend a little bit of time just on the problem motivation, because I think the pandemic has heightened our awareness of this phenomena. And then I'll talk a little bit about this is a research projects that me and my co-authors have been working for the last 4 or 5 years. So, and we have many things emerging out of it that we are continuing to work into the future. And so I will talk a little bit about the ongoing work as well. So what's my motivation? I think what we have right now, we are essentially in some sort of the situation where there's a perfect storm of chronic diseases and public health failures. I don't know, this is like the third wave of the pandemic or something like that. Pandemic has certainly heightened our awareness. And there's deeper issues in our society, which is that of healthcare, health literacy disparities. In many areas, whether it's chronic conditions or infectious diseases like COVID, there is sort of this huge gap between, there's a lot of advances in treatment, but adherence to any, the guidelines that doctors give you when you go to a doctor's office, you usually get like a couple of sheets of paper. Adherence has not been the same level. So that is, some years ago, me and a few other of my co-authors, we started thinking of this problem of, there is this vast amount of user-generated content, and almost 1 out of 7 or something like that, 1 out of 8 search queries on Google are healthcare related. Millions of videos purporting to be about healthcare on platforms such as YouTube. Is there some way that we can leverage this sort of plethora of information that's available and make it more actionable and usable for people at the point of care? And this has been in the last 1 year. National academies have put out these assessing health misinformation. There's been roundtable. The World Health Organization has come up with this guidelines on, can we have these global principles for identifying credible sources of health information on social media? National Academy of Medicine had these discussions. In our case, we've been sort of working on some of these for a little bit now. And so we're happy to see that there is sort of more broader public awareness of this issue. And I should point out that social media platforms are themselves very, very aware of these challenges, are themselves working. Garth Graham, a physician leader who's at YouTube, and he's actually been brought in to especially address this issue of how to identify credible health information sources on YouTube as well. And so I'll talk a little bit about all the different things that we've done. But our motivation is really sort of to, just when you go to the doctor's office, you get 2 sheets of paper. What if we can find, out of this vast amount of user-generated healthcare content out there on platforms like YouTube, if it's possible to find efficient information retrieval mechanism where we can just give 2 videos and tell people, watch these 2 videos, right? So our approach is really like a digital therapeutic for health literacy. Can we just find an automated solution that evaluates videos from the perspective of patient self-care or health literacy, and that can aid clinicians? That's been our goal. So I should point out that what is one of the challenges with this approach? Well, this study that I'm citing here, it's one of the earliest published in JAMA, does this content analysis of YouTube videos on immunization. So doctors actually watched videos and rated. Now, obviously, there is a lot of junk information content out there. But what's the other interesting thing about the study is just the number of videos, if you can see in the column. Asking physicians to watch and rate a video is really, really expensive. Their time is, we can't just find good annotated content. And so one of our big challenges has been, how do we build these for our methods? Even getting high quality annotation was a big challenge, and we had to start with that problem. So I would say two issues that we had to deal with in our approach. One is annotation, other is the scalability of the approach. How well can it scale for a large volume of? And these are some general problems of identifying credible information on YouTube. A lot of problematic YouTube content. One of the things that has been highlighted is that you have all these auto recommendations. Yes? Is there a question? Also, just the problematic recommendations, extreme views, misinformation, distrust. So many of the folks here are aware of all that literature, right? But who are credible sources for health information? I think the Surgeon General, Vivek Murthy, and others have identified this as a priority issue as well. So one thing is maybe we can have crowdsourced efforts to help us in identifying what is misinformation. That has not been our approach, although we can build on some of those crowdsourced in developing our retrieval mechanisms. But we've tried to, one thing but that we have decided is, who are the credible sources? Is Dr. Fauci a credible source? There's a lot of distrust? Is the credible source of healthcare information, is it the Mayo Clinic or is it anything else? So our approach has been essentially the following. We've said that there is a lot of user-generated content out there. Some of it is by Mayo Clinic, but some can also be, if you have something like an ACL tear, there can be a video uploaded by maybe a physical therapist, and it can be very, very effective for you to self-diagnose your condition. So we want to consider the credible healthcare information source as something much broader than only content created by the authoritative medical information providers, meaning we just we want to consider medical information as something encompassing nutrition, lifestyle, guidance, whole lot of things like that. So we started with our focus on one condition, right? How do we identify content that's medically relevant as well as understandable? This National Academy of Medicine webinar, in a sense, said that high quality information needs to be understandable. It's also essentially what is an authoritative source. And so in a sense, what we've been trying to do for the last few years kind of anticipated some of these issues. So our approach is combining three different things, really. There's a lot of literature on health information seeking in the healthcare informatics area. We looked at some of that. We combined it with methods from machine learning to actually build our classifiers. The third thing is just we need tools from causal inference to say that what's a metric to assess how users perceive the information encoded in videos. We've just working with now some grants from the National Institute of Health. Future, I think one of the approaches is maybe should we consider doing a randomized control trial? We didn't do a randomized control trial till now because first, we still are working on our problem, which is how do we identify content that's medically relevant? And second, how do we assess how users perceive the information encoded in these videos? So we looked at collective engagement with the videos itself as a proxy for how users seek to understand and manage their healthcare conditions. And as I said, two issues are just finding the annotated, high quality annotated data sets itself, as we had to create our own. Second thing is just having a scalable approach that scales for sort of millions of videos. So there's a lot of literature out there, but most of these literature didn't really help us much in terms of building our constructs, so to speak. So we really needed to find a simple conceptual model. This is that there is health information seeking behavior. And we said these are two things we will focus on. From a perspective of tractability, information needs to be understandable, and we need a way to quantify whether video has medical information or not. And then we will assess the collective engagement with the videos. And that is a proxy for how maybe users interact with the information encoded in these videos. So our data collection, first, we needed to create a corpus of data from YouTube, which is representative of what users are looking for when they go and search for healthcare information. So we worked with some doctors, and we came up with, there is actually for diabetes, there is a site called Daily Strength, which is really a community forum for diabetics to help manage their condition. So if you know about diabetes, there is like pre-diabetes, there's different stages of diabetes. So I think according to a lot of healthcare guidelines, a lot of people could be at risk for diabetes, given that our lifestyles have become more sedentary and the kind of lifestyles we lead and so forth. So what we really need in building our data is we need to have, if we just get doctors to give us queries on what diabetics need, that's only getting us a very high quality healthcare search terms. What we want is, we want to have a mix. We want high quality. We also want a lot of junk queries from people who have absolutely no idea about diabetes and do like miracle cure for diabetics. If someone's going and looking for that on YouTube, I want to capture that as well. That's how I get the long tail of search queries. That's how I can build a very representative data set of what people are looking for when they go to YouTube. So my search keywords, therefore, I get from Diabetes Daily Strength and helped by some annotation from doctors. And then I can get metadata from YouTube videos, which gives all these title, description, topics, and who's the content owner and so on. So I can use as one of my features is this, if something like Mayo Clinic or NIH or the CDC, that can be used as one of the features in building my classifier as well. So our machine learning pipeline is that we have these diabetes related keywords, use YouTube API, and need to use, we also use the Google Cloud platform and use Google Video Intelligence we've extracted the videos and we used basically different aspects of the videos. I will talk about that in a little bit as features for a different. So I assessed basically the understandability of information from a patient education perspective and how much encoded medical information is contained in the video. So these are essentially two things. Then we also used Qualtrics we worked with, once we have our corpus, we build our classifier. Then we use a tool called Patient Educational Materials Assessment Tool. We had to develop a method to automate essentially the guidelines that have been developed from patient education management literature. So this is basically our machine learning pipeline that enabled us to do various aspects of this, like build a tool, analyze different aspects of these videos from health literacy perspective and healthcare patient education perspective. Then we can actually ask doctors to watch our videos. We did kind of 2 layers of annotation, which I will talk about in a little bit. So yeah, from the perspective of analyzing our videos, we collected the metadata from each channel. We also collected the video features itself. And so there's different things like the readability, syntactic analysis, semantic analysis, and medical entity recognition. So different aspects were all encompassed in the data pipeline. So what are 2 things then we studied? First, we need some way to identify, does this video contain medical information? Now, does that mean that I have a classifier for misinformation? No, it doesn't. I have to clarify my question up front, right? So building a classifier that says, is this video contain medically, what should I say? Is this video have information that's that I could classify as medical misinformation turned out to be very non-trivial. So we did not start with that problem. That's actually right now we are working on this classifier, and we can use topic models and more unsupervised learning methods to classify the metadata into types of misinformation. But that's something we are doing now. We did not start with that problem. And I just want to clarify that because a lot of people in the audience may be wondering if I'm actually, am I measuring misinformation? We did not start by trying to measure misinformation. We wanted to measure, can I classify a video as it contains medical information, yes or no? So the question then is it possible to, just like you can lie with statistics, you can put medical terms in a video and make it look like it's misinformation. And, that's a sort of an adversarial learning problem. Now, that's something that we've considered. But again, to begin with, we wanted to really simplify our problem. We said, let's just measure if there is medical information contained in the video. So can I classify this video as, does it contain medically relevant terms or does it not contain medically relevant terms? And what is amazing is just that simple classifier alone will help me screen out a lot of junk quality videos. Because if you go to YouTube and you type in something like diabetes, the top 10 queries, some of them will be absolutely nonsensical, have like some miracle cure for diabetes, and it has nothing to do with diabetes whatsoever. So even building this classifier actually is a very good way to filter out a lot of junk videos on YouTube. So that was our approach. So let me now define my problem. How do I identify, from looking at a video, what are the features I need to classify whether this video has medical terms or does it not have medical terms? So there is actually this library of there is something called UMLS, Unified Medical Language Syntax. It's developed by the National Library of Medicine. And so the guidelines define medical terms in terms of disease, treatment, symptom, condition, procedure, component, etc. Right? So basically, any kind of medical information can be expressed as a relation between these things. So, for instance, metformin treats something, or something is a precondition or a symptom of something else, or cough is a symptom of COVID, for instance, right? So, what is any medical relations can be essentially you can express medical vocabulary in terms of relations between things. We simplified the problem even more. And we said, let's just use a named entity recognition. So what I'm trying to do is a medical named entity recognition, where I can look at the video metadata for each video. I don't even need to extract the video features. From the video metadata description alone, can I classify this video as, does this video have medical information? Yes or no? That's the first starting step, what we started with, right? Now, what's a challenge in terms of our method? There is something called clinical named entity recognition methods. Those were used for clinicians, for people who work with EMR and other kind of data sets. In my case, this is not doctors talking about health conditions. This is consumer health vocabulary. So this is patients talking about their health conditions or anybody else using extremely informal language. So what my classifier needs to be able to do is to recognize consumer health vocabulary terms, which are not expressed in very non-standard usage, if you will. So that's what I'm trying to do. So going back to UMLS, the Unified Medical Language Syntax, is a dictionary-based approach. I need a method of classification which has to outperform just a dictionary-based classification approach, because I have a consumer vocabulary and it has to teach itself. Now, I should point out that some of you may be using BERT and other models. So we started this work like 4 years ago. At that time, there was nobody was using BERT, or at least we didn't, not widespread enough. But in today's world, what we did was we used a method which is a bidirectional long short-term memory, a BiLSTM model. But I think the same, you can use more attention-based, like a BERT-based model would be pretty good, which is what I've done now in more recent work with health queries. And again, BERT does very well, better than the UMLS, I should say. So what then we have to try to do is UMLS has something called MetaMap. The MetaMap is like a dictionary-based approach, which recognizes different health conditions by body parts. It's a chemical, something is a device, something is an event, something is procedure, and something relates to different aspects of people, right? So for this study, the UMLS semantic type, we can operationalize it with different examples. So there's like a chemical, can be insulin, metformin. So what we need, in other words, we need UMLS, but we need annotated data which is very specific to diabetes. So we actually had doctors helping us for the annotation part in the initial phase of our study, right? So that's what we try to do. So what are some challenges in terms of recognizing medical terms in YouTube videos? Well, one of the biggest challenges is recognizing the boundary of medical terms. So if there is something called plasma-free fatty acids and there's elevated, the elevated is part of plasma-free fatty acids, and that will throw off our classifier. So it required some sort of adjustment in our annotation method. But as we could see, the false positives in terms of like inclusion of wrong acronyms, etc., was less of an issue. With basically the deep learning based architectures do a better job of getting the classifier to train themselves with to recognize medical terms. And that's just some examples for anyone who would be interested, right? So performance evaluation, this is a recurrent neural network using bidirectional long short-term memory. And why bidirectional long short-term memory? Why not just an LSTM-based approach? Well, there is, in a sense, there's the sequence between words is also important in understanding sort of word associations. And that's why a bidirectional long short-term memory would sort of outperforms other methods, right? So basically our method did pretty well. So what can we do then? We did one more, which is, first we needed to recognize, one study we did was just looking at videos, we classify the videos from, do they have medically relevant terms? And can we look at the engagement with the videos and see how medically relevant terms are predicting, say, engagement? And I think no surprises at all in our study. What we find is the videos that are more popular are the ones that have less medical terms. So in other words, somebody searches for diabetes, goes to YouTube and looks for, finds some long explainer put out by maybe the National Institute of Health, which is talking about diabetes is caused by this and metformin and lipids and something and plasma and whatever. And people are like, oh no, I'm bored. And then they'll go to some other video, which is like a crank video, which is cure diabetes by doing these 5 things every day. And those are like super, super popular. So again, no surprises to anyone. This is human nature, but that's what our study also finds. So from there, we said, let's ask the next question. Can we dig a little bit deeper? Yes, we all know that, it's all boring talking about anything medically related. But can we dig a little bit deeper into what patient education literature says? And can I find something else? Are there any normative guidelines? Because remember, that was really our goal, is to help not just maybe the video search, improve the process of video search, but we also would like to find good guidelines from patient education perspective and so on. Any questions from the audience? I feel a little nervous if I'm talking for too long without any questions, especially because this is on Zoom. But anyway, I'll wait for questions. So let me talk about the next step, which is how do I classify whether these videos are understandable from healthcare perspective, from a patient education perspective. So there is a tool called Patient Education Materials Assessment Tool, which was developed by the AHRQ, American Healthcare Research Foundation, or something like that. But this is one of the... So one big question for us is, if we want to evaluate videos on YouTube from a health literacy perspective, what is even a good method? Because there are a lot of guidelines that are put. CDC has something called Clear Communication Guidelines, Clear Communication Index. There is the HRQ has PMAT, some other different kinds of healthcare organizations have put out, there's some national health literacy, I would say, surveys that are done every year. And so there's some normative guidelines already exists. And this was a question we faced a lot from when we applied for funding from NIH as well. NIH reviewers, people in the National Library of Medicine, they want to ask us, why are you looking at this versus some other, right? Our reason for that is just, understandability of materials from a patient education perspective. I think there's a natural, like a consumer psychology kind of an angle that we could make the transition and say, is this video understandable from a patient education perspective? This is something that can scale to outside of healthcare and health literacy. There's just a lot of other videos on, a lot of people are using YouTube and other video platforms they're putting out, for example, a lot of educational software is out there, and there's teachers are posting a lot of tutorials on YouTube, etc. We felt that this approach is something understandable from a patient education perspective. These methods can be scaled to sort of a variety of settings. So what did we do? We've basically tried to use a human in the loop approach. Essentially, what we are taking is a guideline that is developed in patient education literature, and we are trying to build algorithmically, can we mimic the same thing? The question is, again, annotation is a challenge, but building the classifier, what's a good way of building that classifier, right? So what we have is, we used a method called, there is the Patient Education Material Assessment Tool, which basically says, a video is understandable when consumers of diverse backgrounds and varying levels of health literacy can process and explain these key materials, right? So this, basically our approach is a little bit, for almost 50 something years or however long, they've been guidelines to evaluate video-based education materials. But the question is that no one has taken those guidelines and transformed it into some algorithmic sort of a scale where, can I just take the scale and make it into something that can be automated? So I think that's really one of the things that is a contribution of our work, right? So what did we do? We extracted different features from YouTube videos. So we can use methods from object detection. We can use methods from detecting if there are short changes. We can transcribe the speech. We can detect text from OCR, etc. And so what does this allow me to do? It basically, patient education guidelines will tell us that a video is understandable when it has material which is structured in chunks. It describes clear actions. It describes things in certain format. There has to be a sequence. So I've been able to take the videos, extract their features, and using basically a lot of prior work in action detection and other OCR and basically video analytics, I can use those as inputs to my classifier, which is going to evaluate, is a video understandable from a health literacy perspective, from a patient education perspective, right? So we had basically people who are familiar with patient education They have to be given. So this is somewhat of an expensive process of annotation and training. The research assistants need to have some prior knowledge of what patient education literature says, and then they can evaluate videos and then basically annotate these videos. And then we did a second level of annotation, which is that we have a lot of doctors watching the videos and saying, would I recommend this video? Yes or no. So those are basically 4 medical experts. They were surveyed on whether they would recommend this video from a patient education perspective, right? So I have essentially 2 different classifiers. This is a method called co-training, which is not a very cutting edge method. It's been out there in machine learning for some time. The advantage of using co-training method is that it allows me to run 2 classifiers in parallel. So there's a classifier which uses video metadata, one classifier which uses the features from the video itself. And what do both these classifiers do? Since the patient education materials assessment tool, the PMAT, tells that a video meant for patient education is considered understandable when it has all these things. It should make its purpose evident. It should use common language. It should use active voice. It should provide summary, and there are a whole bunch of other features, right? So that's basically how I'm looking for automatic readability index, or can I do the text? How recognizable is it? I can look at the transcription, the confidence of the transcription, the confidence score, that tells me how clear is the speech in the video and so forth, right? The number of summary words in the video description can be a good proxy for, is this material nicely summarizing? And so PMAT also says that if there's any text, it should be easy to read. And then basically the whole bunch of features that I can extract from the metadata as well as the classifier, co-training considers 2 different classifiers running in parallel. And this is why it is human in the loop. When both classifiers F1 and F2 have high confidence label, then that's a good classification. But if there is inconsistent prediction, if classifier F1 predicts something with high confidence, but F2 predicts with low confidence, then what I can do is that we can have a third person who will annotate these videos and resolve that discrepancy. And it's an iterative process. Essentially, I start with a labeled data set, and then I'm generating labels for the remaining, and I have to go through this till every video is classified in my sample. And I do have, there were a few sort of things that fell through, it was hard to classify either way, and some of those robustness checks, we had to do a lot of evaluation, but it turned out to be a surprisingly good method in terms of predicting whether these videos are understandable or not from a patient education perspective. So it's basically a loop. We train classifiers, and then we have these self-labeled examples. This is like a pseudocode, right? And just to evaluate how well are these, from a machine learning perspective, I have to look at my methods and say, are these, how solid are they from a predictive accuracy perspective? And the ROC curve shows that using these co-training methods with the logistic regression versus other methods like random forests and so forth, we had to do some checks with other neural network methods and so on. And what we find is turned out to be surprisingly robust in terms of predictive accuracy. And this was really for us to have confidence in our method of prediction. What we really needed was this. We then recruited doctors to say, would you recommend this video from a patient education perspective? So precision at K is a method from information retrieval. So how well is our algorithm doing in comparison with what medical experts would recommend? So we find that our algorithm is actually, with a larger number of annotated samples, no surprises again, it was doing pretty well, even comparison with what the experts would rate as, is this understandable or not understandable? So to give some confidence in our own predictions, sort of, right? So now what do? We look at it from the other way around, which is I have these measures to assess whether videos are does this video have medical information? Is this understandable from a patient education perspective, right? Then what can I do? I have to look at, I need to quantify essentially how users are engaging with the videos. So there are, from the metadata from each video, we can look at the number of views, number of likes, dislikes, neutral comments. We can look at basically the cosine similarity between what's in the comment and the description of the video, cosine similarity between the keyword of the search and the video description, and between the comment and the titles, and so forth. So what do all these things tell us? We did a principal component analysis on these collective engagement measures. So there are basically three categories of user engagement that we can find. We find there is basically like a non-engagement measure. It's loading negatively with almost all the measures. So anyone who's worked in any online setting knows that, it's like a bounce, like you have these bounce ratio measures. You go to a link and you just immediately bounce from it. It's a measure of sort of non-engagement or disengagement, if you will. It's user feels that this is not really relevant to them. So that's one category of engagement that we can quantify. And the other two different categories, what we call selective attention-driven engagement is really a popularity-based measure. And then there are more sustained engagement, attention-driven engagement is more a relevance-based measure. So the principal component 3 is really loading highly with more of if somebody is searching for more highly health literate search term, like a fatty acid or lipid or something, glucometer, something with more medically relevant search term, and they get into the video and then they watch the video, the cosine similarity between the search term and what is in the title of the video or the comments of the video, description, etc. That's sort of tells the difference in health literacy of the users who are searching for content, right? We did not start by thinking that we will measure that, but that was something that we actually found as we started doing more of this work. So what does my work then tell me? It tells me that there were three distinct findings that we could come up with, right? First, just model-free evidence alone. Something is what my method would classify as high in health information encoded in the video. The popularity was automatically low, right? It was not very popular. So the popularity-based engagement measures were not high. But the second thing we found is for this third component of the sustained attention-driven engagement, which is more of a relevance-based engagement measure, we found that the videos that were high in medical information actually were good at engaging. So the higher health literacy users who are looking for, people maybe who read Lancet and maybe JAMA, and they go to YouTube and they're searching for maybe medically relevant terms, maybe then they are the ones who will discover the videos put out by Mayo Clinic, and they're watching them and maybe rewatching them and engaging with the video according to what my measure would show me. And so all is not terrible. So there is still some hope maybe for humanity or hope for users, heavy users of YouTube. So that's basically what we find. We find essentially three different things. If we can do a simple 2x2 of low medical information, high understandability. The most popular, the videos that are low in medical information and high understandability, they are the ones who are, that's really the most popular kind of videos. Again, no surprises, right? I think there's a lot of literature on healthcare misinformation, and some of it is just rooted in cognitive biases of people. Something that's easily understandable is, automatically stuff that people will easily engage with. So from our perspective, we had to spend some time thinking about what is really the implications of this work. How do we sort of tell policymakers? How do we inform folks on? I would say that at least a 2-level screening, filter out these junk information quality, and then look for understandable videos, and maybe recommending understandable video is good, provided there's some kind of a screening check. But otherwise, a lot of popularity measures are just basically correlated with higher understandability, but there's not much of authoritative health information in those kind of queries. That's what our work is finding, right? And so what else did we do? We also tried to do some sort of like a hygiene checks, really. Can we recruit some experts with, we looked at top search queries on YouTube, and then we re-ranked our search results according to what our own measures, understandability, medical information, relevance of the measure, and so on, and would examine the video, and we asked the doctor, would you recommend this video to patients? So this is some ongoing work that we are doing into looking at sort of more positive approaches to how to mitigate the problems of misinformation in videos. And as you can see, if something like diabetes, for top 10 search queries, would our method recommend these videos? Yes or no, right? Turns out that from the perspective of if you're looking for filters on understandability and engagement, then there would be some videos that YouTube will recommend would not be recommended by our method. And again, what is good is also that some of the top ranked videos are actually, YouTube has made a lot of efforts to improve their recommendation process. So they do allow a lot more control in today's world to the user. And they've also made a lot of effort to highlight authoritative medical information sources. But again, as I think one of our work is that the authoritative sources of medical information are not widely available for all healthcare conditions and all sorts of, I would say, the whole range of symptoms or what patients really need. You can't just make a few videos from Mayo Clinic and, creating medical information in a manner that's engaging to users is actually it's an expensive process. And that's like really one of the goals of our work, is how to broaden this process of discovery of content and use more, not only broaden the definition of what can be considered medically relevant information, because it goes beyond what the clinicians would tell you. It has to encompass a lot of other stuff: diet, nutrition, exercise, patients talking to other patients, whole lot of stuff. For instance, in the area of cancer and other conditions, we've seen that YouTube videos have become a place to recruit patients for clinical trials, for some kinds of chemotherapy treatments and so forth. So there's just a lot of other things that are going on. And so we are broadening our problem to consider a whole lot of other things. First, I think our contribution to practice is that from a health literacy perspective, there's not a lot of rigorously evaluated video educational materials. So what we are trying to do is just developing some library of videos using user-generated content. And the benefits would be that can basically improve medication adherence and assess health information needs and so forth. And what are some other policy implications? I think at least at a very minimum, it's a hygiene check for when doctors recommend any video content. So when videos have lower medical information, low understandability, at least these would be junk videos. And from the perspective of identifying what is medical misinformation, it's actually very helpful to look at videos in this bucket. That's what we are finding in some of the subsequent work we are doing. What else? The ones that have high medical information, but not very understandable, we definitely need better guidelines to help healthcare providers create better, more engaging content, right? And the videos that are understandability is high and medical information low, this really is one type of misinformation that we should, though it's not really, I'm not classifying these videos as misinformation per se, but the potential to misinform is very high in something that's very understandable and uses a few medical terms. And so I think that's one of the things that we are really working with doctors and working with also some folks from the National Academy of Medicine into helping us build this kind of a pipeline where we can actually we started with diabetes, we've broadened to other conditions. We now have chronic, we have a data set from COVID videos. We've also trying to broaden it to other such as procedures, surgical procedures, and so forth. So the idea is, again, maybe we can use methods such as transfer learning to take the classifiers that we've already built and sort of use it for different conditions and so on. Yeah, Sinan?
Hey, Anjana, this is great. I had a question.
Yeah.
Did you find videos in that sort of top right quadrant, high medical information and high understandability, and thus would be engaging? Did you find videos in that quadrant?
Yes, we did find videos in that quadrant.
And
yeah.
What are sort of the basic characteristics of those videos? In other words, what distinguishes them from all the other videos? What makes those videos? What are their what are they like? What are their characteristics? Who are they made by? Or, how do they, what are those videos?
Yeah, I think there should be a short paper we should write just based on your question to answer. But yes, I mean, what are some practices that we can, I should say that I should have included some of those examples maybe today, but it's something for me to think about. At a very minimum, what I myself talked about some of these features, right? In terms of these videos are good at sort of structuring content in the sequence and describing actions or describing things that patients can do, right? The other thing is, yes, most of it is probably made by authoritative health sources. But do I have any questions that, do I have, something like this. So diabetes causes, symptoms, diagnosis, treatment, something like this, right? That was considered the diabetes insipidus symptoms. So the best practices are, the videos that were made by some healthcare organizations, which probably considered, maybe they were made with the help of a patient education expert. It's not surprising that we would identify them as both high in our, right? So I don't know if that answers your question, but yeah.
It does. Thank you.
Hongi and then Zen.
Yes.
Yeah.
Thank you, Anjana. That was great. So I had a quick question about to what extent can we take the results here and sort of apply it to other sort of jargon-heavy topics like, I don't know, climate change,
yes,
or nutrition, I guess, within the medical sphere. But I think climate change is a big sort of debate out there, and there's also misinformation, and I think it's very difficult for the average person to understand the literature. So how does that apply?
Yeah, I mean, I've been thinking about the climate change aspect as well. There is no guideline like a patient education guidelines that you can readily develop. But in the climate change kind of a thing, I think using something like a GAN type of a model, like an adversarial network type of a model, where you have the potential to misinform people using scientific jargon and terms, right? So it'll have to be an adversarial learning type of a problem. So I think one approach is, in recent work, I've used counterfactual inference, methods from counterfactual inference. So I think that's probably, if you're looking at climate change, the adversarial learners or counterfactual attention-based, I think that's the direction to go. Getting annotated data is actually not as challenging because all you have to do is find this, maybe a textbook or some sort of an online repository, and you'll get all the terms. But what is misinformation is much more insidious. The other area I was thinking a lot about, but not actually have done much, is education, because there's a lot of, in K-12 type of settings, teachers and have developed a lot of content and posted it on YouTube. Is anyone actually assessing this and saying, is this actually correspond to, common core standards or what have you? And so I think that's another area where I've thought of. So Zanile, you had a question.
So for this understandability metric, you talked about kind of the video analysis side. Are there any challenges with, since this is kind of a jargon heavy field, kind of maybe the original model, both like for readability and for the translation of the transcripts maybe is like geared towards not as, I guess, like medical information driven metrics. So is the metric that you're using for readability one that's specifically for like kind of this medical context, or is it just kind of counting? Because I guess I would imagine in some jargon heavy contexts, just the existence of medical terms might be more, might be kind of penalized in a way that's not maybe exactly like aligned with the original idea of readability.
Yeah. And in fact, one of the things I'm thinking about is also just the fairness of these recommendations. In other words, if I'm looking at readability, the idea is that I'm looking at consumer vocabulary of health terms, and I'm trying to understand how people engage with the videos on YouTube. In a conversations with people within YouTube itself, one of the things they've highlighted is that if you're trying to measure, even if YouTube actually has this problem of how to recommend content, they would like to recommend authoritative sources. But what happens? Authoritative sources are not very popular, right? So that's the challenge that YouTube runs into. Now, another question is, if you're taking something like this automated readability or any readability type of index into building that sort of measure of maybe understandable, etc., there may be some racial or other ethnic biases, because this is a common problem in even hate speech detection. A lot of some of the specialized maybe dialects or languages is used differently depending on which community and so on, right? So the fairness of the recommendation is something that we have to consider as well, in addition to understandability, because my understandability measure may be penalizing some kinds of ethnicities, or it doesn't consider the fact that, and so the question of recommending content depends also on the relevance. And I see a question on who should bear responsibility for improving videos. Is it providers, search engines, consumers, regulators? I would actually say that in some sense, all of these people bear different kinds of responsibilities. We certainly need more algorithmic accountability from the healthcare for the platforms themselves, or some sort of policy guidelines need to be there. But the basic question still remains, I think, with these readability type indices, that they'll only capture some amount of, right, the variation. So it is an imperfect measure. So I don't have really a great answer to your question, I think.
No, that's a good point. Yeah, for example, for one of my projects with using, I'm trying to create transcripts, there's this kind of bias based on accents, like kind of the confidence of the transcripts, even though, listening to the transcript, a person might be listening to the video, a person might still recognize the speech. A lot of the speech recognition systems don't have the same level of confidence, even if it's kind of similar level of like understandability for a consumer. So yeah, it's a challenge.
Yeah, and I think that, a lot of the sort of emotion recognition AI faces some of these issues as well, that it does not recognize. There may be some gender or racial or other kinds of biases that's not easy to see how we can overcome them, because the standard methods for bias sensitive recommendations will mean that you need annotated data set where you can take that protected attribute. But here it is very hard to infer who is the content creator, who is it. So the whole issue of video recommendations and fairness is a very, very challenging aspect, and we are ourselves grappling with some of those issues. Right? I still have a little bit more time, about 3-4 minutes to answer more questions if anyone has. So yeah, I think the other thing that we try to do is, the next step of our, the last step of our work, or rather what we are trying to do is just getting more bias aware data collection. And how do we have, we have this corpus of videos on 2 chronic conditions, 2 infectious diseases. So one of the things we'll have to do is, then can we do better NLP methods to do basically some sort of some of the questions that people have asked me during this presentation itself, right? There's like a more adversarial misinformation using medical terms, or there is the question of how representative are the recommended methods across maybe for different conditions. And the third thing I think I have to say is that something like diabetes itself, it may be a condition that affects maybe a broad set of population, but within different subgroups of the population, there are very different manifestations of, say, diabetes. So if someone's going to YouTube and looking for recommendations on diabetes related videos, that still does not answer the question of what's the intent of the person. In some sense, the platform like YouTube has to do its own sort of projection of what a person is trying to find, and then provide them with some relevant information. So there can be questions on for certain minority groups, there are some kinds of disease markers or some prevalence of certain conditions, and that's not generally captured in the general population. Is there something we can do to sort of make our method of recommendation? Again, this is an issue of how to debias or make a more bias sensitive recommendation. But that's like sort of another aspect that we are considering as well. So I think I'm almost out of time. It's 12:59. Maybe I have time to take a last question or something, or. Yep, almost exactly on the dot.
Awesome. Yeah, it doesn't look like we have any more questions in the chat, but this was an amazing seminar, a lot of really interesting results, and I look forward to seeing more about this work come out in the future. And I just want to take a moment to thank you and to announce we'll have another talk on March 24th, which will be David McCoy from NYU. And yeah, everybody have a great afternoon.
Thanks, Anjana.
Thank you, Sinan. Thank you, everyone.